When testing two independent samples, most statistics assume equality of variance. Thus, it is helpful to know if your samples have equal variances. When investigating equality of variance, we test the null hypothesis that both samples have the same variability. The alternate hypothesis is that they are not equivalent. Because this is a hypothesis test, you also need to establish your alpha. There are several statistical tests that you can run to evaluate this, but the most common is Levene's test for equality. The formula looks like this. Did your brain explode? Luckily, this is something that you'll never need to calculate by hand. Most statistical packages have this solution built right in and will run the analysis for you. In fact, Excel does too. More on that in a moment, though. But let's imagine that you are a glutton for punishment. There is a formula that you can easily perform by hand. You can use Hartley's Fmax test rather than Levene's. You simply divide the larger variance by the smaller one. This gives you an F ratio. If the variances are similar to each other, then the F ratio will be close to 1. The more the different variances differ, the larger the F ratio will be. To determine if the F ratio is statistically different from 0, you will need to find the probability of obtaining that F value. To do this, you need to know the degrees of freedom, which is the total number of people in one of the sample groups, minus 1, and K, the number of groups. In the case of Fmax test, K is always 2 because you are comparing two groups. Note that this test assumes that there are equal numbers of participants in each sample. Finding the critical value needed to reject the null hypothesis is very similar to how you would do this for a t-test, except that we are using a different distribution. We are using the F distribution that is based on the two components that I just mentioned, the sample size and the number of groups. The F distribution takes on various shapes based on these two values and the alpha that was selected, but it is always skewed to the right. You can find F tables online or at the back of many statistics books. How do you find the critical value, though, using one of those F tables? The first step is to select the table for the desired alpha. This is an example of an F table for an alpha of 0.05. Now, you simply go over to the column that has the degrees of freedom for your sample size, which is n-1, and then down to the row with the number of groups, 2 in this case. If the obtained value for your analysis is larger than what it is in that cell, you reject the null hypothesis. Okay, let's take a quick look at how this works for the equality of variance hypothesis test. Imagine that sample 1 has a variance of 12.65 and sample 2 has a variance of 17.89. There are 12 people in each sample group. To calculate Fmax, you divide the larger variance by the smaller one. In this case, 17.89 divided by 12.65, which is 1.41. The F value for alpha at 0.05 with 11 degrees of freedom for the sample size and two groups is 19.4, which is clearly more than 1.41, meaning that we fail to reject the null. The variances are equal. You can also evaluate the equality of variance by leveraging a spreadsheet that Wayne created that estimates the confidence interval around this ratio. You don't have to assume equal sample sizes in this case. If you use a spreadsheet, the variances are considered equal if the confidence interval contains 1. They are considered unequal if the confidence interval does not contain 1. In addition, Wayne will show you how to use F-test formula in Excel to determine if variances are equal. See, Excel can make complicated statistics oh so easy.